Okay, guys, today we're going to learn about solving inequalities. Now, solving inequalities is very similar to solving equations. Your goal is still to isolate the variable on one side of the inequality, just like we do with the equation on one side of the equal sign. Now, the rule also applies that whatever you do to one side of the inequality, you must do the same thing to the other side. So you got to keep that balance, just like with equations. The one difference is that whenever you multiply or divide, specifically by a negative, okay, only when you multiply or divide by a negative, you will need to reverse the direction of the inequality. So if it's less than, it's going to become greater than, or if it's greater than, it's going to become less than. All right, so let's go through a few examples. Now, let me see. Let's move this up a little bit. We're going to have to get those words out of our ways, because what we're going to be doing is we're going to be solving each inequality, and then we're going to graph it on a number line, because we've learned how to graph an inequality on a number line. So we're going to get the solution, and we're going to graph it on a number line. So here we go, get those words out of our way. All right, so we've got x plus 5 is greater than 12. All right, so what we're going to do is we're going to isolate that x. So we're going to start by subtracting 5 from each side. And I want you to show work just like with equations. So the 5s will cancel, leaving us with x. We're going to keep our same inequality symbol, which is greater than, and then 12 minus 5 is 7. So we get the inequality x is greater than 7. So any number that is greater than 7 will work in that inequality to make it true. So like for example, 8 plus 5 would be 13, and 13 is greater than 12. But if you went less than 7, it wouldn't work. Like say 2 plus 5 would not work, because that would just be 7, and 7 is not greater than 7. So then we graph on a number line. We're going to draw a line, arrow at either end, and you only need to kind of do the portion where there's 7. So I could put like 7 in the middle, and obviously it would go 8, 9, and we could go show what's lower, 6, 5. Now, since it's just greater than, it's going to be an open circle on 7. Okay. And then we would draw x is greater than 7, so it would be an arrow to the right. So there's our x is greater than 7 on a number line. Okay. Example number 2, we have 3 is less than or equal to b minus 1 1/3. So we have to isolate b. So we're going to add 1 1/3. And we're going to add 1 1/3. So we ended up with 4 1/3 is less than or equal to b. So if we draw this on a number line, okay, what I would probably do is I'd go 3, 4, 5, 6, and we got less than or equal to 4 1/3, or well, 4 1/3 is less than or equal to b. So 4 1/3 would be somewhere right about in there. We could even write 4 1/3 underneath that. And remember, 4 1/3 is less than b, so it actually would fall in, the arrow would go to the right, because like 4 1/3 is less than or equal to 5, 4 1/3 is less than or equal to 6, right? So that's why the arrow goes to the right. And it's a closed circle, because remember, it's or equal to. All right. Number 3, b plus 5/7 is greater than 2. So to isolate that b, we'd have to subtract 5/7 and subtract 5/7. All right. So we'd have b greater than, and it would be 2 minus 5/7 would be 1 2/7. Okay. So again, we draw our number line. Okay. And I would go like 0, 1, 2, and 1 2/7 would probably be somewhere right about in there. That would be 1 2/7. So we'd have an open circle because it's just greater than, and b is greater than 1 2/7. So the arrow would be going to the right. Okay. Now, number 4, we have 6x is less than 42. So to isolate that x, we divide by 6 on both sides. So we'd have x is less than 7. So there's our inequality for our answer. So when we draw the number line, we could have 5, 6, there's 7, 8, and 9. And it'd be an open, because it's just less than, it'd be an open circle on 7. And x is less than 7, so the numbers that are less than 7 here would go to the left. Okay. Now here, number 5, we've got b divided by -8 is greater than or equal to -6. Now in order to isolate that b, we'd have to multiply by a -8. Now here's our first time we're hitting that one exception. There's one thing that's different than solving equations. When we multiply or divide by a negative, we have to flip the direction of the inequality or reverse it. So we're going to have b, and then -6 times -8 is a positive 48. But instead of keeping it greater than or equal to, we're going to change the direction of that and make it less than or equal to. And that's going to be your new inequality. Okay, so then when we graph that on a number line, we would have like 46, 47, 48, 49, all right, and then it's or equal to, so it's a closed circle on 48, so we're going to fill that in, and b is less than or equal to that, so we're going to do arrow to the left. All right, let's look at number 6. Okay, -5x is less than 45, so to isolate x, we're going to divide by -5, and divide by -5, and again, since we're dividing now by a negative, okay, we're going to flip that direction. Instead of less than, it's going to become greater than. We're going to flip the direction of the inequality. And then 45 divided by a -5 is a -9. Okay, so when we graph that on a number line, okay, we'd have like -11, -10, -9, -8, -7. And it's greater than, so it's an open circle on 9. Okay, and x is greater than that, so arrow to the right. All right. Let me move this up so we can see the next few examples. All right, number 7. This is like a kind of just like a multi-step equation. We have a multi-step inequality. We have 2x plus 7 is greater than or equal to 13. So we're going to deal with our adding and subtracting first. So we're going to subtract 7 from both sides. We get 2x is greater than or equal to 6. Then we're going to divide by 2, and again do that on both sides. We don't need to flip here, we're dividing by a positive, so it's going to be x is greater than or equal to 3. So any number, if you plug it in, that's greater than or equal to 3 will work in this inequality. So if we graph this on a number line, we could go 1, 2, 3, 4, and 5. Now this is or equal to, so we're going to have a closed circle on 3. And x is greater than or equal to 3, so we're going to have our arrow to the right. And again, if we plugged in any number greater than 3, like say we plugged in 4, 2 times 4 would be 8, plus 7 would be 15, and 15 is greater than or equal to 13. So we're showing all those numbers that will work in that inequality. So let's look at number 8. Again, it's multi-step. We got the opposite of x divided by 5 minus 12 should be less than or equal to 8. So we'd start by adding 12 to both sides. Get the opposite of x divided by 5 is less than or equal to 20. And what I'm going to do at this next step is I want to get rid of both that negative and that 5. So I'm going to multiply by a -5. Whatever I do to one side, I have to do the other. So I'm going to get x, instead of multiplying by a negative, I'm going to flip the direction of my inequality or reverse it. So it's going to be greater than or equal to now. It's going to be a -100. So if I draw my number line, graph this, I could have -102, -101, -100, -99, -98, and it's going to be a closed circle on 100 because it's or equal to, and x is greater than that, so it's going to go to the right. Okay, now we can also solve word problems that are inequalities and do the same steps that we've done before with defining our variable. In this case, we're going to make it an inequality. We're going to solve it, check it, and write a sentence. So number 9 says, Macy is making each of her friends or her 7 friends a bracelet. She does not want to spend more than $42 on the bracelets. Find the maximum cost for each bracelet. Well, what we don't know is we don't know the cost for each bracelet. So when we define our variable, we're going to let X equal the cost of each bracelet. Okay, so she doesn't want to spend more than $42, so we really want her cost to be less than $42. Now, she doesn't want to spend more than that, but she could spend at least that, so we're going to make it less than or equal to. Okay, she doesn't want to spend more than that, but she could spend that 42, so that's why I'm making it or equal to. Now, she'd find that cost, but basically she's X for each bracelet, and she's making it for 7 friends. It would be 7 times X would be what give you the cost. So we want that 7 times X to be less than or equal to 42. So to isolate that variable, we divide by 7. We get X is less than or equal to 6. Okay, so to check this, okay, what we do is we pick some numbers that are less than or equal to 6 and make sure they work in this inequality. Like we could even test 6 as 7 times 6 less than or equal to 42. Yeah, 42 is less than or equal to 42. Or we can even try, like, say 5. Say 7 times 5. Is that less than or equal to 42? Yeah, 40 is less than or equal to 42. It's less than, so it does check. And then we would say the maximum cost for each bracelet is $6. Couldn't go over that because that would put us over that 42. All right, guys, I want you guys to turn over the paper and pause your notes. Try the practice problems, all 1 through 9 practice problems, and then we'll go over them. All right, so flip it over and pause your notes in 3, 2, 1. Okay, guys, let's quickly go over these practice problems and see how you guys did. So we got to solve each inequality and graph it on a number line again. So for the first one, to isolate that y, we're going to subtract 5 on each side. And we get y is greater than 6. And then when we graph that on a number line, we would have an open circle on 6. And y is greater than 6, so the arrow would go to the right. In number 2, to isolate that h, we would add 1.5 to each side. And we get h is less than, it'd be 6.5. 2 wasn't very good. So h is less than 6.5, so if we draw that on a number line, okay, 6, 7, 5. Well, halfway between we'd have 6 and 7, we'd have an open circle halfway between 6 and 7, and you'd have your arrow to the left because h has to be less than that. You could even write a 6.5 underneath that. Okay, number 3, to isolate that x, we'd have to subtract 5.7 and subtract 5.7. When you're subtracting decimals, make sure you line up your decimal point. You want to add a 0 there. When you subtract that, you get x is greater than or equal to, it's 5 and 55 hundredths. You have to do some borrowing. All right, so graphing that on a number line, it's kind of just like a sketch. Okay, 5 and 55 hundredths is about halfway between 5 and 6, so you'd have a closed circle on between 5 and 6, and x is greater than or equal to that, goes to the right. You can even put 5 and 55 hundredths up above if you wanted to on that one. Okay, let's move this up. Number 4, to isolate the y there, we'd have to divide by 4. We'd get y is less than or equal to 7. When we graph that on the number line, we would have a closed circle on 7 because it's or equal to, and y is less than that, so your arrow would go to the left. Okay, number 5, I would want to multiply by a negative 3 on both sides to get rid of both the negative and that 3. And this is one of those cases where we got to change the or reverse the direction of the inequality. So we'd have W is less than, it'd be a negative 39. All right, so we would have, when we graph this, okay, we'd have an open circle. Oops, actually I gotta do my negatives. Oops. Let's see. Let's do some erasing. Obviously, with negatives, you got to be careful that you make sure you get the number line in order, right? So this is a negative 39. So greater than that would be a negative 38. And to the left would be the negative 40. Got to make sure to include my negative. Okay. And an open circle on negative 39, and W is less than that. So arrow to the left. So be careful when you're doing number lines with negatives. Obviously, I almost made a mistake with that. All right. Number 6. We got to divide by a negative 8 on both sides to isolate that b. And since we're dividing by the negative, I'm going to switch that direction of that inequality. So we're going to have b is greater than or equal to, it'd be a negative 7. So there's my inequality. So let's see if I can get this number line right this time. So it's negative 7. So over here we'd have negative 6. This would be negative 8 to the left. And it's or equal to, so it's a closed circle on negative 7. And b is greater than that, so arrow to the right. Okay. Number 7 here. Let me move this up. Okay. So we'd start with adding 17 because we got to add or subtract first. So we'd have negative 10y is greater than or equal to 50. Then we divide by a negative 10. And since we're dividing by a negative, we got to flip the direction of the inequality. And we'd have y is less than a negative 5. Or less than or equal to, excuse me, a negative 5. And drawing this on a number line, negative 6, negative 5, negative 4. We'd have a closed circle on negative 5, and y is less than that, so arrow to the left. And then in number 8, we'd subtract 22 from both sides. We'd have 2/3 w less than 12. Okay, and then to cancel the 2/3, it's dividing by 2/3 or multiplying by the reciprocal, which is 3/2. All right, we can do some cross dividing. And we get W is less than, oops, better W, 18. Because we do 6 times 3. And when we graph this on a number line, we could go 17, 18, 19. And it'll be an open circle on 18 because it's just less than. And W is less than that, so arrow to the left. Okay, let's look at the word problem. It says Juanita is going bowling and has $25 to spend. If each game costs $4, find the maximum number of games she can bowl. So what we don't know is the number of games bowled. So we're going to let X equal the number of games bowled. That's what kind of we want to find out, how many games she can bowl. That's what we don't know. Okay, so she has $25. Okay, so she can't go over 25. But she has 25. So she could be, her amount's going to have to be less than or equal to that. Okay, she can spend up to 25, but not over that. Okay. And each game costs $4, so 4 times the number of games will give us our total cost. Now, here, to isolate this, we divide by 4. Now, I know this doesn't go out and come out evenly, but that tells you something. X would have to be less than, if you divide this, 25 divided by 4, it's like 6, like you could even go 6 1/4, because it'll go in 24, but you want talking money, so it'd be $6.25. Okay, or actually $6.25, 6.25 or 6 1/4 games, I should say. Not talk. This isn't money; it's the number of games. So she has to do less than 6 1/4 games. Okay, so let's check this. Let's test if it would work if she played 6 games. Well, if we do 4 times 6 is less than or equal to 25. Well, 24 is less than or equal to 25. So she could play 6 games. Okay, you go over that, you're gonna be in trouble. So that kind of checks. So we could say the maximum number of games she can bowl is 6 games. Okay, hopefully this went well, guys, and we'll work some in class tomorrow on some of the same stuff. All right, see you tomorrow.